Well, good morning, everybody. 1 minute to go to start our webinar. My name is Victoria Ballesta. I'm Marketing Manager for EMEA, Nexeo Plastics. And we have today this webinar on bio-based materials to replace fossil-based plastics for injection molding and also 3D printing. We are very lucky to have here Natalie and Daniel from Stora Enso to explain everything about bio-based materials. So for those who is first time in a webinar in Zoom, just we'll let you know that you can write here at the at your screen. You will see an icon with the chat. You can write your questions there. We will answer all your questions or at the end of the webinar, or maybe at the middle when we depending on Natalie and Daniel. And it's 11, so I think we can start. Okay, so welcome everybody, and let's start. I would like to tell you first that we are recording this session, and in a few days we will be uploading this webinar to our website, nexeoplastics.com. You will receive an email with the link and the information, and you will be able to see it again at our website. Just for a start, let me present Hector Mas. Hector is the Director of Product Management for ETP and Specialties and Marketing at Nexeo Plastics in Europe. He has over 20 years of experience in plastics with an automotive OEM, a tire one molder, and a resin producer. And he also has a broad experience in product management, of course, in sustainable materials, which started in SABIC, no, Hector? And now continues here in Nexeo Plastics. So I pass the floor to you, Hector. Thank you very much.
Thank you, Victoria. Let me start with a brief presentation of Nexeo. 1 minute about who is Nexeo. Is a company that we do plastics distribution in North America, in Europe, and also in China. We are quite a big company, above $2 billion or euros. We are more than 700 employees, and we work with a lot of top-class suppliers. And today we have Stora Enso here. We have more than 11,000 customers. As a distribution company, that is normal. We supply all kinds of markets. The main ones are automotive, healthcare, packaging, E&E, and we can count all of them. Our job is to do all the supply chain services that customers are asking or are expecting from a distribution company, but as well complement this with ADs, application development engineers, to make sure that we can help our customers to be successful with the materials we sell. And finally, of course, being a distribution, we sell a lot of products, and we are active in 60 countries. Jumping into the sustainable discussion today. Today is the second webinar that we organize about sustainability, and I would like to revisit a couple of slides that I used in the previous one. And one is this one about how disruptive we see the sustainability for plastics. I think we are changing the way we have been working on plastics traditionally, where we look at the performance and the cost, into a new situation where we have a third axis that is about sustainability. And then we can start thinking all what we do about what is the impact that is from the sustainability point of view. And I think this is a complete change for plastics, we think. And as an example, we use the ecographies. I think it's very visual, the change from the 2D ecographies that we had in the past to the 3D. The experience that we have with the 3D is completely different. This is what we think is happening these days with the sustainability in plastics. The other slide that I would like to use today is why we do these webinars at Nexeo in Europe about sustainability. And the reason is very simple. There is a lot of negativity around plastics. This negativity, we know, is very often not based on real data. It's often a campaign about how bad things can be, but the reality is slightly different. So the reason to start changing this mindset is just to share science, real data about the things that we do. Okay, and this is very linked to what we are going to discuss today, because Stora Enso has developed products that are really based on data, and we'll revisit this data later on in the presentation. And the third thing is, I mean, these products are already available, are commercial. So we are not talking about things that will happen in many years from now. We are going to touch things that we can start using in our normal life. So it's not about future wishes. It's really about realities that we could use. And today the presentation, I would like to touch a new topic, which is the carbon footprint. Okay, I think starting from the left, I think we have a kind of common understanding, common vision that we want to reduce the emissions. Okay, the CO2 emissions. But the issue or the dilemma is we want to do it. I think maybe I'm naive, but I think we all want to do it. But we want to minimize the impact. The impact means on not in the emissions, but also in the performance or in the price or so we want to do it, and we have to find a way to do it in a feasible way for all of us. And one potential solution we have for this dilemma is just look at the nature. I mean, nature is using carbon for their life, for its life. So we have a potential solution that is just using trees that they consume CO2. So in this case, you will see now in the slides from Stora Enso, I think they have developed fantastic products that they use trees. They are backwards integrated into trees, into very nice forests, and we can really we can use these new plastics based on wood that are almost half wood. There are the different grades, 40, 50, 55, but there is really wood in there. And the funny thing is, we use the carbon footprint to really compare solutions, how sustainable they are. We need to look at the life cycle analysis. That is the way to really look at the data. In this case, Stora Enso has developed products that are even negative in carbon footprint. That the first time I got it was counterintuitive. Negative cannot be negative. Yes, it is negative because we use the tree. So you will see this in some of the slides from Natalie. So we really like these products. I think they're very interesting. And I would like to start thinking what applications you have if you are transforming plastics that could be used with wood, because I think it is by nature sustainable, right? So let's look at the details from Stora Enso. So I'm going to introduce our speakers. Natalie Calivas is project manager for innovation projects at Stora Enso, and she is leading the biocomposites effort. He's targeting to replace fossil-based applications, and he has been always working on this circular economy approach from Stora Enso. And then we will have as well Daniel Evalson, that is the technical support, so he will be ready to answer the technical questions you may have during the presentation. And he joined Stora Enso 26 years ago. He is working on the circular solutions and is responsible for the technical support and the developments of the biocomposites materials. Natalie is going to take the lead now on the presentation. We are going to have two blocks. We'll do injection molding first. We have a small break, so remember to put to write the questions in the chat. We'll have the first answers after the first block, and then we'll have a second block about 3D printing, and then we'll continue answering injection molding if there is still things pending, and potential new questions for 3D printing. So, Natalie, the floor is yours.
Thank you very much. Let's see if I can share my screen. So, I think it's working. Good morning, everyone, and thank you so much for attending this webinar together with us and Nexeo Plastics. As said, my name is Natalie Calivas. I'm located in Stockholm, Sweden, and I'm here together today with my colleague Daniel Evalson. And as Hector just briefly explained, we have around 40 minutes together now, where we will have structured this session into 2 blocks. So whenever you feel you have a question, please write it in the chat, and the chat can be found in the little black instruction part on your screen right now. There's a fourth part says chat. Write any questions you might have. I will stop after the first block. We will answer some of the questions, and then we will review the rest of the questions in the end. So we will start off talking about biocomposites for injection molding, and also in general what biocomposites are. But first of all, I would like to just shortly mention Stora Enso, of course. Stora Enso is a Swedish-Finnish company located in Northern Europe. And our purpose is to do good for the people and planet. And by this, we think that by replacing fossil-based materials with renewable products, we can contribute to a positive climate change. And that is our main purpose that is driven through the whole company. And also a lot of our materials that we are now developing and producing and selling is intended for a circular economy, which we believe can be used if we have the tree as the foundation, since it can grow and be used again. So Stora Enso is a global company operating in most of the continents all around the world. It's a leading provider of renewable products. We've been mainly known for our packaging and wooden construction and paper. But in the recent years, 5 years back and more, we've been focusing a lot of R&D and innovations, and to see how we can innovate on what a tree can do, meaning that biocomposites, which we will present soon, has been available on the market since 2018. And the reason is that we have, due to the fact that we have the tree as a foundation, we also have a lot of different waste products connecting to other processes and products. So what I will talk about here is how we have found a way to innovate on our own waste, meaning the wood fibers, and what we can do with them to extend the lifetime of a product. So what is a biocomposites? And this is the beauty. The biocomposites is developed with the intention to replace a fossil-based plastic. Plastics itself is not necessarily always a negative product, as it's been outlined so much in media and in discussions. Plastics can have many different application areas and is developed with the intention to do good. However, we have now found a way to make it in a bio-based version, and also to extend the lifetime with combining it with the wood fibers. So the biocomposites itself is created out of 2 different raw materials. We combine polymers with our wood fibers. So starting off with the wood fibers, the polymers, sorry. The polymers could be eco or fossil-based. The eco version is the material contains renewable feedstock, meaning that it has a traceable origin, and we can buy it from different suppliers in Europe. So the feedstock that we use for this eco version contains waste and residues from vegetable and cooking oil streams. This means that the material itself is not produced with the intention for the plastics only, but it's a waste product from the beginning. So it contributes to a circular lifetime, and that we can now found a way to found a product that we can use this waste and residuals from. So we take these eco polymers and we combine it with our own wood fibers, which is a waste product from our sawmills here in northern Sweden. So depending on what type of application, we have different grades, meaning that we also have grades with different amounts of wood fibers. So we combine the polymers with 30 to 55% wood fibers, which results in different, what we call them, product families, which are pure, plus, and prime. These are only names for us to understand, separate the different categories or applications depending on the application's requirements. Pure, I can say, is materials in its purest form. We have the least additives combined with the material itself. Plus has a little bit more flexibility to the mix, and prime is where we have extra additives that we can replace other types of plastics. But in general, pure and plus are intended to replace typically PP, PE, or PS, and the prime grades are our, what we used to say, would replace engineered plastics such as HIPS or ABS. But I will go more into the applications areas a little further down in the presentation. But just for you to understand, to the left on this slide, you can see the surface of what injection molded biocomposite will look like. So for some of the grades, we are able to use larger fibers, and for some grades, we use smaller fibers. But the beauty is that the fibers are visible in the material. This sets the material a little bit apart from what's normally called plastics, since it has a different texture and structure to the surface. This is also the natural color of the product. Combining the wood fibers, meaning yellow beige wood fibers with polymers, which is transparent, gives this beige camel color to the product itself. So when buying the granules and injection molding, everything will look this yellow, but anything can be master batch into a preferred color. The material can never be transparent because the wood fibers are there, and I would say that it can never be fully white. It can never be bright white, since there will always be a touch of this yellow tone to it. But later on, I will also show some pictures of products, and you can see that depending on amount of master batch, you can get it in a pastel color or more bright blue, bright green, and so forth. For our biocomposites, we recommend that the design and the molds have walls above 0.8 millimeters, meaning that it's a fairly rigid product since there are wood fibers combined in the material. And as said, it can be colored into basically any color. We also know that when looking for a more dark color, such as gray or black, using the large fibers, the fibers will still be visible in those darker colors, but in the smaller ones, they will almost be covered, depending on the amount of master batch used. But as Hector has talked about, this material is intended to replace fossil-based plastics. And why we're doing it, as Hector has mentioned, is that we have just found a complement or an additional material that can be used in order to lower the CO2 and emissions relating to material itself. As talked about, we can use two different types of polymers, either the fossil-based or the eco-polymer, and combining it with our wood fibers. The tree has already itself collected the CO2, which is why we have a negative footprint from starting off when we're using this material. Using a fossil-based polymer with a wood fibers still has a lower CO2 impact, and I will show you a graph on this in a minute. But the main intention for using biocomposite is to have a material that will help you reduce your CO2 footprint. The material itself, biocomposites, is also intended for multi-use products, meaning if the material is used for bowls or cutlery and such, it can also be dishwashed. So the intention is that it's supposed used for reusable products and not single-use products. The beauty itself also is that if you are able to sort the material after usage, after the product is finished, if you're able to sort it, collect it, you can also remold it, shred it and remold it and reproduce it up to 5 times with the same technical characteristics of the material, meaning that it won't lose its properties even when remolded and reproduced, which will potentially happen to some plastics. Also, when if biocomposites is recycled, meaning thrown in a bin, it will be treated the same way as PP in a waste stream, meaning that it can be recycled. So looking at the graph, we are try to present how the main benefit of the CO2 reduction can happen by using biocomposites. Here in blue, we have found the typical plastics that we think that we can replace: ABS, PP, and PS. In the yellow, you see the biocomposite CO2 footprint when having produced it with fossil-based polymers. And in the green is where we have combined the wood fibers with eco PP, sorry. And as you can see, and as Hector explained, we have a negative starting point for our eco grades. This is because, as Hector explained, in the beginning, from the start, we have CO2 stored in the tree that we use, and it won't be released until the product itself is incinerated. Meaning when we sell the grades, here the calculations are made on cradle to gate, the CO2 footprint are negative. And then again, due to production and transport and so forth, this will change for the product itself. But when receiving the material, we have a negative starting point. We can please add any questions you might have to this, and I will try to explain further if it's a little unclear and it's a little complex. I totally understand. But as we talked about in my first slides, we have 3 different areas or 3 different grades families where we have different types of technical requirements. So depending on what products you are looking for, we can suggest or recommend different type of grades. Each of these families contain around 3 types of grades with different types of characteristics. The pure one, as says, has the lowest amount of additive, works perfectly fine for more products with very little or no technical requirements, such as cutlery, such as bowls, such as anything with just a lot of strength. The Plus family has enhanced flexibility. So for this case, there's a hanger, but it could also be toys. It could also be furniture, for example. And within our prime category or family, this is our latest development with the intention to replace engineered plastics, such as electrical appliances or sports and safety gear and so forth. This is still grades that are under development in the sense that we are constantly looking for feedback on how to improve these in the right way. There are requirements such as UV, flame, or other technical parts that needs have material to work with them. And this is something that we constantly collect to improve these grades further. And we're happy to do this together with Nexeo Plastics to also reach a broader audience for these types of clients. So I brought 2 different customer cases, we can say, for injection molding parts. First of all, we have this Quachetti. It's an Italian producer of toys. And they reached out to us last year looking for a bio-based alternative for them to have for their new line, which they call Quachetti Play Bio. Quachetti has a lot of educational toys in different variants, depending on the children's age, and thought that you can't really see it in the picture, but they have large fibers visible in the material due to the fact that they early on wanted to inspire children to a new and sustainable and green material to the products. What's also needs to be said is that our material has the required EN certification that is for European toys. So it works perfectly fine for toys for children of any age. And their material holds 30% wood fibers, and they combine it again with the eco-based polymer, meaning they have an almost 100% bio-based material to their customers. And what we know and what we have heard is that the market has responded very positively, not due to the fact that the material gives the texture and the visual aspects of the material feeling of a natural context, meaning that the colors are quite soft. There's a little texture to the material, which makes it less glossy than what children normally are then used to. I also wanted to include another type of project that we've just recently launched, and I don't know why that last sentence is white. However, Magis is a premium furniture company, also located in Italy, which released a new line of bio products at Salon de Mobile in June this year. They were looking for a new material to also, again, from a customer perspective, be able to attract new types of customers. So they believe that choosing our material for the backrest of these chairs, they were able to attract a new target group, which has normally only been looking for bio-based or more natural touch to their products. And again, this backrest contains, in this case, 30% wood fibers to maintain the requirements that they might have. That was the first part of the block, the presentation that we prepared. And I can see that we have some questions already. Maybe, Victoria, can you maybe read them for us, or Hector?
Sure. Yes.
And again, sorry, for those who hasn't already sent questions, please use the chat to post more questions.
Yes, we have very interesting questions here. So, first question from Alex. He's asking us, he's saying, we tried material with wood fiber not too long ago. It smelled like a sawmill in production. Products got to retail, though you need designs that are optimized for that sort of material.
I think, Daniel, you can take this, but in terms of the smell, yes, there will be a smell in the beginning that will vanish.
If it smells like a sawmill, that is okay, I would say. It would be much worse if it smelled like something was burned. But for some products, yes, some of our material could be too brittle, but for some products, it would work just fine, especially if you are able to use the Plus family materials. Then we can replace a lot of already existing products. With the Pure family, it's more rigid products that we can replace right away. But of course, if you redesign the product, you will have the best benefits from the material.
You mean redesign the mold?
Yeah, the product, it's the same thing.
Okay.
Hector, did you have something to add?
Yes.
Yeah. I would like to also share our experience as Nexeo. Customers complaining, that is smelling born. We are transforming wood. So what do you expect? So we are heating up, so it's smelling wood. So, but it's okay. It has to be like this. So we should get, and this is also linked to the, if it's brittle, we are very familiar at transforming glass fiber, carbon fiber, other kind of things. So now we need to understand how to work with the wood fibers, and we need to adjust the design, adjust. Of course, there are certain things we need to learn, but it's normal. I think it's a new direction that we could explore, and we can discover applications and so on. Yeah.
Good. Thank you. Then another question from Auntie is saying, please confirm if kraft pulp means pure cellulose fibers. What is the wood species? Fiber dimensions?
The wood species is spruce. The kraft pulp is soft. It's a softwood from either pine or spruce with bleached. So it's it's a pulp that we buy internally in Stora Enso.
Okay. And could you give us information about the fiber dimensions?
Fiber dimensions. I mean, for the S materials, the material can have the single fiber can have a length up to 0.7 millimeter and a width up to 0.2 millimeter. And for the L materials, the length can be up to 1.5 millimeters and a width up to 0.5 millimeters. But then we have a spread within the material. So, I mean, in an L material, you will also have some S fibers. So all the fibers will not be the size I just explained.
Okay.
Yeah.
Thank you, Daniel. Okay, we have another question here from John. Is there a food grade in biocomposites that can be used for food packaging?
Yes, our materials are food approved in Europe. And these are grades both within the Pure and the Plus family.
Okay, great. Another question, what type of material can be used to produce zinc brush blocks?
What was it called? Zinc brush blocks?
Zinc brush blocks.
Zinc brush blocks.
Can you take the question again, because you in my speaker you faded away a little bit.
What material can we use to produce zinc brush blocks? I'm not entirely sure what that is, so maybe that could be a question we can come back to
Okay, yes, sure.
in the follow-up.
Sure, no problem. Then another one, do you have composites with bioplastics from renewable origin?
So the bioplastics is renewable in the sense that, or not renewable, sorry. We only have it from waste and residuals. We don't have it from renewable sources.
And another question from Alex, how do these yogurts...
Wait, Natalie, I think the bio-based polymer, the eco line that you produce, this is renewable origin for the base resin and for the wood, of course, no?
I mean, the polymers in that, Daniel, maybe you can correct me here, but the polymers are made out of feedstock from vegetable and cooking oil. And correct. I'm not entirely sure how if they define it as renewable, yeah, or just as a...
I think they do.
They think they do, but I don't want to say something that it's not 100%. So, I mean, it has a bio origin, but yeah.
Correct.
Right.
So this ecoline is fully renewable for the base polymer plus the fibers. Yeah.
Okay.
Okay. Then we have this question about the yogurt spoon taste. Alex is saying, I tried such a bio-based spoon and it tasted horrible. Don't know the exact material. Could have been bamboo.
Yeah, I mean, we have sold a lot of materials for cutlery and such things, and we have never experienced that our material have left any taste. We often, when we have our cake here at the office, we often use our own cutlery and our own material, and it doesn't taste nothing. So that is not an issue with our material.
No.
Okay. Thank you. Then for bio-based toys, do you have FDA also?
No. That is a process that we have initiated, but we haven't, it takes a lot of time on. So right now we only have the certification for toys in Europe.
Okay, thank you.
And food approved the materials for the Europe legislation.
Yeah.
Okay. Is the material suitable for exterior applications?
Depending on the application and depending on what we mean with exterior, we are right now doing tests, UV tests to develop material that can be used for sun and wind and water. Depends on the requirements of the customers, but yes, to some extent we can have it outside. But if you place it northern Sweden in constant rain and snow, I would say no. There are still fibers in the material which will absorb water. But again, I mean, it's dishwasher approved, so I mean, it can withstand the water. It just depends on the requirement itself.
Okay. And did you ever test your materials for automotive applications? Yes?
Yes, we are currently undergoing developments with the large automotive companies within Europe, and it's for now going very well. So we stay very positive for the automotive industry.
Great. Do you have experience molding a one-piece chair?
A one-piece chair?
I understand
Is
a
it
chair.
like a full piece?
Yes, molding.
Yes, Daniel, we have that, right? In the office even.
We have that, and most success, of course, we have been when we have used less fibers. So I mean, we have some materials with only 30% fibers, and those ones have been the easiest to injection mold in one piece chair, of course, since the size is quite big. But today we could probably even use 40% material for that type of application, I would say.
Okay.
Let's take two more and then we can proceed.
Okay. Yes, because we have a lot of messages here, a lot of questions.
Yeah, I can see. That's great.
Do you see potential to expand this technology, biopolymers, wood fibers to plastics for other applications, extrusion, yarn spinning?
Daniel, any comments to that? It's not something that we have focused on.
What was the question? I mean, expand it to
new technologies, to technologies such as biopolymers, wood fibers, extended to plastics for other applications, extrusion, yarn spinning.
Well, we do have some development projects on the extrusion side. On the yarn, I don't really know what you mean, so that I can't really answer.
But for extrusion, we're not as positive as we are with other development projects. I wouldn't promote our material to work with that.
I mean, the grades that Nexeo is supplying, none of those grades are optimized for extrusion, so they are more for injection molding.
Yes.
Okay, I think we have a lot of questions. I would suggest that we can compile the questions and prepare the answers, and then after the webinar we can send an email to all those people registered with this little booklet compiling the questions and answers. So like this, because I see more than 30 new messages coming, so I see it's very interesting. So I wouldn't like to give up, but maybe we can go on to respect the times and go with the answers further to everybody who registered. Is that okay? I hope it's okay for everybody listening. We'll do our best. So we keep on going. Yes.
And I will try to be a little more descriptive, so you have potentially less questions.
Yes, and we can also maybe send the TDS and some information that can add some value information too. Yeah. Don't worry, we will go through the questions. Keep on writing.
Yeah. That's great. We have only a few slides focusing on biocomposites for 3D printing. Currently, Nexeo supplies what we call the biocomp standard grade, which is what you see to the left, which is the yellow material, if we want to just make it super simple. This material is what we have on shelf today. It combines 50% wood fibers with 50% bio or fossil-based polymers, just as we did for injection molding. This material is available, it's commercially available and can be found through Nexeo Plastics. However, in Q1, we're also launching our new 3D printing granules, which we will name Biocomposites Ocean, where we combine the 50% wood fibers with 50% recycled fishing nets. That's why it's green. The color of the fishing nets combined with the wood fibers makes this fantastic green color to the structure. I just want to highlight, it's not recycled fishing nets in the sense that the fishing nets has been picked up from the water. It's used fishing nets that never ended up in the water. So we haven't we haven't cleaned the ocean in that sense. It's just that we saved the ocean for having this type of waste coming. These two products can be used for large scale printing. Due to the fact that we have 50% wood fibers in the material, the 3D printing will still, the applications for 3D printing needs to be large and can't be thin or details. We wouldn't recommend to do any small products or any detailed products. And we have lots of questions from architectural firms saying, can we produce these model pieces? No. I would recommend pieces that are more into interiors or wall structure in that sense, or wall separators as such, because the products, it's still quite rigid when printing it. It's a robust material, and we usually it's used for 2, 4, 6, 8 millimeters nozzles. Thinking also that due to the wood fibers, the material moves quite slow when printing. That's why we always recommend soft shapes and not hard angles. And at this point, the material is slowly used recommended to be used for interiors and not exteriors. We are undertaking some UV tests and UV developments with this type of product, but we also know when people ask for products for exterior with large scale pieces, they also think, can we put a chair outside? Yes, you can for a while, but I wouldn't recommend it. The fibers will expand, the product will look messy in the end. When printing with our biocomposites, the biocomposites can only be found as granules and not as filaments, meaning that the 3D printer needs to be adapted for that type of product. And what can also be said, no, I think I said it all actually, for now. But we recommend larger pieces for this type of application. And here are just examples of what's been done previously. In the yellow part, you can see this is a fair boot, and it's both tables, chairs, and the wall application in the back, or the wall separator. In white, here is 3D printed wall shapes again. This is actually printed as a wave in the front and as a flat back, and then placed on the wall, and it's used for store interiors. And in the bottom, you can see fantastic green chairs. Actually, these are chairs placed in a sushi restaurant that they're of the shape as of seaweed in its sense. And the material here works very well, meaning that the ocean material in a sushi restaurant just makes a perfect combination. So the yellow material is available. And as you can see, you can color it in the sense that you can paint it or spray it into other, like for example, into this white. That is, of course, practically doable. And thinking of if you're considering the after finish, we would recommend sanding. It works quite well. It needs a machine. I wouldn't say you could do it by hand, because it's still plastics that you're sanding in the sense, but it works. So you can get a flat surface if that is required for the product. That was it in terms of for 3D printing. Great. Do we have any 3D printing questions?
We have. I've seen some comments. Okay. Here we have a question for 3D printing saying, Could the 3D printing material used for each machine, or is there a special machine necessary? Do we need a
No,
special machine? No?
The granules can be used. I mean, a lot of 3D machines today are has granules or polymers in the granule format normally. So it works very well with any type of 3D printer for that.
It
Yeah,
should
but
be
it needs to be
FGF.
granular printed.
Sorry, now you both talked. Hector, do you want to start?
Should be an FGF printer, so fused granulates fabrication. So this is quite common and getting more popular these days. So there's a lot of choices for this kind of printers.
Great. And then what's the base polymer material for the fishnet chairs?
PP.
PP. Okay. And do you have experience with coating the chairs for outdoor applications? Which coating?
I said we are doing some development tests with it. I can't say that we have found the optimal solution yet, so I wouldn't make any recommendations at this point.
Okay. Can you treat the surface so that it's UV stabilized? When are you thinking achieving the UV test? Do you have a...
We are hoping that we will have a solution by Q1, but I won't make any promises on that one.
Okay, no problem. Good. Any more 3D printing? Thank you. Yeah, okay. No more 3D printing questions. We can recover some of the former questions if you want.
But I'm thinking, as Victoria previously mentioned, if we will formulate a follow-up email to all the participants who's been here today, where we can include the technical data sheet overview of the grades, our standard grades, which Nexeo Plastics supply. And then I'm thinking that I think I can try to summarize all the questions that we received. I see it's a lot, which is fantastic.
Yes.
And I will do my best to formulate an answer so that we can share, so we can all get an understanding of what they're looking for.
Sure, perfect. Yes. Okay.
Any final remarks from you, Hector? Anything that we should add or forgot?
No, I see we had a lot of people listening. I really see a focus on exterior applications. So there is the extra step we need to go. I think the UV, the coatings, any idea to find a way to do it exterior will be nice. And I'm very happy with the attendance. A lot of people, a lot of interaction. The chat is continuous, so it's good. We see that, so I think it's very positive. Yeah, overall. Yeah,
great.
Very good.
Yes, absolutely. So then if you want to send any more questions, we will answer them. Maybe, well, just to finish, I would like to thank you, Natalie, Daniel, of course, Hector. If you have any more questions, maybe later when we finish this webinar, or you want to contact us, you can write us an email to welcome@nexeoplastics.com. We will answer you. We also have some engineers that can help you with this or any issues that can come up. And yes, we will be uploading, as said, this webinar to our website, so you will be able to watch it again if you want, or finish watching it if you didn't have time or you didn't join at the beginning. And please feel free to contact us for anything that concerns you, and anything you want to ask us. So Hector, I give you...
Yeah, I would like to thank you, Victoria, the marketing team, to prepare this, as well for our speakers, Natalie and Daniel, of course. We see a lot of attention, which is good. We truly believe that there are a lot of applications that we could start considering to move already now into these materials. In the future, new things will come, like auto, UV, this will come, but today we have already things available that we should explore together. There are some questions about price and what is the extra in price. Correct. So let's have a discussion on this. Let us know what you want to discuss, and then we can also prepare quotations, send samples, go through the validations, the testing. Is as I said before, is a new kind of material, so we need to learn a lot. We learned already, we need to explore. It's a new thing, which is cool, and we can do a lot of very good things together. So if you have requests, feel free to ask, and then we'll follow up. And thank you for connecting to everyone.
Thank you.
Thank you very much.
Thank you.
Thank you.
Ciao.